In this video we're going to look at calculating relative formula mass. It's quite an important calculation for us to be able to do for a number of reasons. Mainly, I suppose, to be able to calculate, it's part of being able to calculate how much of a product is made or how much of a reactant is needed in a reaction. So a very important calculation in chemistry, and it relies upon us being able to accurately count the number of different types of atom in a compound. Now, if you can't remember how to do that, as part of the balancing equations videos, the first video is all about counting atoms. So I'll quickly run over it here, but if you need more detail, then please go back to that video. So first question here, calculate the relative formula mass. I abbreviate that, and a lot of people do too. MR, capital M, little r, means relative formula mass of water. So we're going to calculate the relative formula mass of water. Now to do that, we need the relative atomic masses of the hydrogen and the oxygen. Okay, now those relative atomic masses are found on the periodic table. So if you were to look at oxygen on the periodic table, it would look like this. It would have a O for the oxygen, a 16 up there, and an 8 down there. Now the bottom number is the atomic number, tells us the number of protons in the nucleus, and therefore the number of electrons on the shells surrounding the nucleus. We use that number for all our bonding diagrams. So we've used that number quite a lot repeatedly. So it's the bottom number, it's the atomic number, okay? It's the atomic number. And we use that, most importantly, we use that for bonding diagrams. Okay, that's mainly what we use that for. Now this top number here, this is the relative atomic mass, or the mass number, okay? Depending on what is exactly on the periodic table. Okay, now the Edexcel periodic table, it's the relative atomic mass that's at the top there. Okay, it's called the mass number as well. Okay, subtly different definitions. But it's this number here that we use in calculations. That's important. So that number there, okay, is the number we use for calculating quantities and calculating relative formula masses. Okay, so top number for relative formula masses. Now, to help us on this sheet, and it's often the way in calculations, in tests and exams and things like that, the relative atomic masses are given in the question. So we don't need to look at the periodic table here, but if these weren't given, you would look at the periodic table. Okay, so two stages to these calculations. First off, you have to be able to count atoms correctly. So H2O, okay, that means there's a hydrogen, the atom hydrogen is there, and there are two of them. The number after it tells us how many there are. Every new capital is a new element, so we then go to a capital O, so that tells us oxygen is present. There's no number after it, so that means there's an invisible one there. So there's two hydrogens and one oxygen. The number after tells us how many of each there are. So we could write that like this, H plus O. So after we've counted the atoms, next thing we have to do is just substitute in the relative atomic mass of each of those atoms. So hydrogen has got a relative atomic mass of 1. So it's 1 plus oxygen's got a relative atomic mass of 16. 1 plus 1 plus 16 equals 18. Now, it's a bit long-winded to write it out that way. You don't have to write it out that way, but to be frank with you, if GCSE, any student I see writing it out like that never gets it wrong. Okay, oxygen next, the O2 molecule. Okay, so it's O2, so it's oxygen with a 2 after it. So if you don't want to write it out like this, you could say 2 times oxygen. Another way of saying it, isn't it? So oxygen has got a relative atomic mass of 16, so 2 times 16 equals 32. Write it out like that as well if you want to. Okay, it doesn't matter how we write them out so long as we get the answer right. Next one here is CH4, this is methane. That's a common name, methane. So it's going to be CH4. Now, capital C, there's no number after the C, and this is a capital H here. So this tells us this is C on its own. Okay, the reason I say that, I mean, let's just imagine we were doing this one here, okay, and let's imagine we were doing that one there. This one here is capital C with a little o, so this little o must go with that capital C, that's cobalt. This is capital C and a capital O, okay, so that's carbon because this is a new capital here, so that's oxygen. This is carbon monoxide and that's cobalt. So capitalisation is important. So C with no number after it, so it's 1 times carbon, so it's 1 times carbon, and H with 4 after it, so that's going to be 4 times hydrogen. Okay, so we could write this out as 1 times 12 or 12 brackets plus 4 times 1, because the 1 is the relative atomic mass of the hydrogen and the 12 is the relative atomic mass of the carbon, equals 16. Okay, so it doesn't matter how you write it out. C2H4, so 2 times carbon, so we could write this like this, C plus 4 times hydrogen, H plus H plus H plus H. And do you see how that way can get a bit long-winded? So 12 plus 12 plus 1 plus 1 plus 1 plus 1. Okay, there's no extra marks for doing it in a smart maths way or just doing it in a long, laborious way. That's going to be 28, isn't it? And you can carry on down like that. I'm not going to do all of these for you. We will quickly just look at this one here because brackets sometimes cause people a problem. Okay, so that's CA, brackets, OH, close brackets twice. Okay, so Ca, that's calcium. Capital C, little a, that's just calcium. So it's 1 times calcium. So 1 times calcium. Plus. Now, O, there's no number after the O, so there's 1. But it's in a bracket. It's in these brackets. Everything inside the brackets is multiplied by the number outside them. So 1 times 2 is 2. So that's going to be 2 times oxygen. Plus H, and there's no number after the H. Okay, but it's in a bracket. Outside the bracket is a 2. So that's going to be 2 hydrogens. 2 times hydrogen. Okay, so calcium's 40, so that's 1 times 40, so that's obviously 40. Plus oxygen times 2, 16. Oxygen is 16, so that's going to be 2 times 16. Plus 2 times 1, well 2 times 1 is 2, so let's just write that as 2 straight away. So 40 plus 32 plus 2 is going to be 74, isn't it? Equals 74. I think I'll leave you do the rest on your own.